Let me give you a small architecture about microservices. Okay, in general, monolithic applications, right? Mono applications, mono applications design used to be like this. Mono applications design used to be like this. We will have front end, we'll have front end, and we will have back end for any number of modules. Let's say your application is having 10 modules or 20 modules. For all that modules, we will have one front end application and one back end application, one front end and one back end application, and we will have all the data into one single database we use in this architecture. So these front ends can be tightly coupled front end or any front end with Ajax also we can implement. If we have REST based calls in the back end, or maybe using request to JSON and response to JSON model, you can have separate front end application, separate back end application, and a database, or tightly coupled front end also, like in your MVC. We create forms and that forms directly connect with controllers without any Ajax calls. With Ajax calls, we can create a separate front end and separate back end. Without Ajax calls, we can have tightly coupled front end and back end code also, like in servlets, JSP is how we used to implement. So this is how we create monolithic applications. Whereas in microservice, whereas in microservice, whereas in microservice, we will have multiple styles here for front end. We can have one front end or multiple front ends also. Consider you have one front end. Just consider you have one front end application. Back end side, we will have multiple microservices. This backend code will be divided into multiple microservices. Let's say this backend is designed for three modules. Okay, for three modules, this backend is designed here in monolithic. The same backend, if you want to implement in microservice, we will break it down into three separate microservices: module 1, module 2, module 3. We'll break it down into three separate microservices. First module, microservice. Second module, microservice. And third module, microservice. A separate application altogether we will implement. A separate application altogether we will implement. For each module, a separate application. Okay, clear? So each module will divide it into separate microservice. Usually here in monolithic scenario, front ends directly connect with the back end, or you can have any gateway also here. Usually we will have tightly coupled front ends. Without any gateways, we directly connect with the back ends. In very less cases, we will see gateways here in monolithic. Gateway means a mediator between front end and back end. Usually, we will not maintain any mediators in monolithic scenario. But coming to microservice architecture, front end will not directly connect with the back end. If you see here in this scenario, we will have one front end, one front end application. In monolithic case, we have one front end and one back end. Third thing you should notice, one database, mostly one database only we will use. And fourth thing, no gateways. Okay, usually we don't maintain any gateways here. Now coming to microservice, you can have one or many front ends. You can have one or many front ends. You can have one front end, or for each microservice you can have one separate front end also. There is no limitation here. One or many front ends you can have, and obviously we'll have for each module or a feature which is independent and deployable. Independent, which is independent, a module or a feature which is independent, deployable, maintainable. Means you have an independent feature that you want to design it as a separate microservice. Either can be a module or a feature. Okay, call it with any name. You can create a separate microservice for each module or a feature, independent feature. You can create a separate microservice. You can create a separate microservice here for backend. And strictly here we maintain separate database for each service. Strictly we will maintain a separate database for each service. Separate database for each service. We will use separate database. Common database is not recommended. Though it is not recommended, I can see in few application people still using common database. Maybe that application is not having, you know, a lot of user traffic. Maybe very less user traffic or internal applications. If they are not unable to afford multiple databases, maybe they can use a single database. But it's always recommended in microservice a separate database is recommended for each microservice. And compulsory we should include here a gateway, a gateway for application, or many also we can have, but strictly we should have at least one gateway. A gateway is required. A gateway is required for a typical microservice application. Okay, so at least a basic microservice application should have this one front end, and here you will have a gateway between your front end and back end. Here you will have a gateway, a gateway between front end and back end. We will have gateway. Generally, if you see monolithic applications, when I implement a backend application, usually my controllers will have a URL right here, a backend URL we will have. During writing, our controllers will put some URL. Let's say this backend URL name is something app URL. If you have directly here, right? This app URL only we will consume in front end also. Same app URL we will consume in front end also. So here we have multiple modules. Each module might have a separate URL. Module URL. Each module will have separate URL. A separate unique path they will have definitely. Each controller will have a separate unique path. So consider each module is having a different URL. Not only module, inside module, controllers also will have different URL. And here in this scenario, you need not to share your module URLs to front end. Just we integrate our modules URLs in the gateway. In gateway we will configure all these modules URLs. and front end can access only gateway URL. Gateway will be deployed into one separate port or in a separate server altogether. So gateway is having a gateway URL. A gateway URL will be sharing that gateway URL to the front end. This gateway URL will be sharing it to front end. Once we deploy gateway, right, we'll get a path. We will share that path to front end. So always front end will call only gateway with the extended module paths. That's it. Maybe with module names. Let's say if you name this module as admin module, gateway URL slash admin. If it is a customer module, gateway URL slash customer, gateway URL slash seller, something like that front end will call. And front end is not aware of your services where they are running, and it is really not required also. It is not recommended to show where you are running your backends. Some kind of abstraction is required. You need to hide via gateway. Gateway will help you in many ways. One thing is it will hide your URLs. It will not expose them. And it is a central configuration server. It is a central configuration server, or you can say it is a filter, kind of a filter, which filters everything before proceeding request to microservices. Let's say you are sending a request from your front end. The gateway will monitor your front end request. In such way, you can write code inside gateway. You can write code in gateway to filter it. Let's say security you want to apply. All front end requests directly, I don't want to send it to backends without applying security. So I can apply security here. Gateway can act like a filter. I can apply security check here so that if requested front end is having authenticated and authorized URL, then only I can forward it to the respective module, or else I can reject that request. So security I can apply here. Anything, any centralized loggings if you want to do, who coming in and who coming, who is logging out. If you want to apply logs, any centralized filter operations if you want to write, you can write here in the gateway. Gateway will help you from that aspect. As you are dividing your backend application into n number of microservices, if there is no mediator, if you give direct access, applying security or centralized operations will become difficult. That's why they introduced a gateway. It will act like a mediator between front end and all backends, so that if there is any centralized operations required, that I can, or if there are any filter operations required, that I can apply on gateway. Without gateway, it will be a challenging task. If you give direct access to front ends to back ends, we don't know who is coming in and who is going out. We can't maintain application easily. So there should be only one path. With that one path only, all the front end requests go to back ends. This is how a typical microservice architecture we design with the front end gateway and back end, and each application, each backend application will have a separate database. Recommended to have a separate database. And if we go in depth, there are so many patterns that we need to follow, but this is the one which high level we should remember first. This is how you need to design a basic microservice application. A basic microservice typical architecture is, we will have one front end, or you can have many front ends also. I don't want to go into many front ends topic now. Consider you have one front end and multiple backend microservices Each backend microservice will have one database, and all these backend microservices will access it through a gateway in the front end. Okay, and during implementation of these microservices, we strictly follow REST implementation. We will implement all services as a REST enabled. So during implementing this microservices, right, we will use REST controllers. We will use REST controllers. We don't put simple controller and implement it. We use always REST controllers to implement it. And we need to talk about the challenges here. During monolithic scenarios, during monolithic application scenario, as only one team used to work on this complete backend and front end, they don't find collaboration issues. They don't find any collaboration or communication issues between team members. They can easily approach each and they can check what you implemented, what I implemented, what is going to implemented in future, how you are creating your application URLs, front ends can connect with back end, and together they can work here. But when it comes to microservice, multiple different teams will work on them. One team will work on front end, one team will work on one module, other team will work on another module. So here communication is very important in microservices. Coding is simple, but as team sizes are continuously increasing, we should have a proper connect with the teams to understand how each designing their service. Otherwise, front end team is working here, five people are working on continuously front end, and there are three teams working on back end. If there is no communication between them, they don't know what URLs you are using. So we should resolve that communication problems also here. Okay, how we do that? And as we have multiple services here, that is one problem. Okay, between teams, collaboration will be one different, one problem. You see, these are not problems actually. These all we should maintain properly in microservices, but consider them like a problems when you compare with the microservice monolithic. Okay, so one is collaboration issue between teams, or communication problems, and documentation. Proper documentation we need to provide. If I design microservice 1, I need to design a proper documentation and I should share, otherwise other people may not understand about my microservice. My team implemented it and other teams wants to know about it, so I need to give proper documentation. So generally we don't write any documentation, we use tool to generate it, like a Swagger, a API documentation tool. Documentation in the sense it will let others know about your microservice design, how many controllers you implemented, right? And what number of URLs you have across each controller, how many controllers you have, and what is the input object and what is the output object. All that can be shared via documentation. So here we have tools for this so that we need not to worry about documentation. And configuration problems, configuration maintenance, configuration. So as we are distributing services into multiple microservices, multiple backends, maintaining configurations will become difficult. As you are seeing only three modules here, you may think it's okay to maintain configurations, but you know, services continuously will keep on increases. It may go to beyond 100 or 200 or 500 or 1000, depends on the application. Microservices count continuously will increase. There is no limit for these microservices. When a business use case is taken up, I have 20 services and continuously that is increasing from 20 to 100, 100 to 150. So your services keep on increases. Maintaining configurations means your database connection properties or port numbers, these all will become difficult. Somebody should maintain them. Okay, so as we have multiple teams across multiple microservices are working on, who will maintain these configurations? Somewhere these configurations need to be documented and maintained. A centralized configuration is required. So configuration problems we have, and anyway we introduced gateway that is giving solution for the common access. So common access issue, there is no common access until unless you provide gateway. So here gateway will provide the common access. And fifth one, security. It is easy to maintain security in monolithic but not in the microservice. In microservice scenario, as we have multiple microservices, handling security will become difficult. Okay, so for security also we need a solution here. Security and data read write, data read write issues we need to address. Data read write issues we need to address, which means when I implement a microservice, when I implement a microservice for a module, and if I address all the, or if I implement all the CRUD operations here, including save, update, delete, everything for this module one considered, but I want to give only read access. I want to give only read access to some front end user. Let's say a user role is trying to access data. For that user role, I want to give only read access. Write access, I don't want to give. So you need to address that read write issues also here. Okay, you need to address that read write issues here. We, you may ask, in monolithic, don't we have that issue? In monolithic, everything is available to the front end, and we don't worry about this front end because back end and front end will be together. One team is handling it. We need not to worry about it. But when it comes to microservice, your microservice may access by some other front end applications also, as it is rest enabled, right? We may give access to some other teams or somebody else who wants to access our API. Just they want to read the information. Let's say weather information we used to see from weather APIs. Similarly, I want to expose this to across my organization as a public, this module one. And when they access it, if you provide read and both write operations, accidentally or intentionally, if they try to do any write operations, it will modify your data. So if you want to give only read only URLs, then you need to address it. Okay. So that one also you need to address. Configuration problems, collaboration problems, documentation problems, and common access issues, security issues, data read write operations. What else? Yeah. Typically, you need to address all these issues in microservice, but we don't have these problems in monolithic scenario. You need to address all these issues here. So collaboration between teams. So it's a management activity. Collaboration between teams. It's a management activity. Let's say if you are a Scrum Master who is dealing with your teams. If you are a Scrum Master, excuse me, you must aware of all the teams who are working on this a number of modules, front ends and back ends. If one front end wants to connect with a back end, or a back end team want to connect with another back end, you should set up a meeting and you should aware that who all working, and you should be able to connect that both the teams so that they can talk each other and they can resolve the issues. And without interrupting other teams, if you want to know more about that particular application, the only other way is documentation. The only other way is documentation. Seamless communication, if you want to see between the teams, the only way is documentation. Let's say module 1 I implemented. If I can provide this module 1 proper documentation, Then other module people want to understand more about my module, they need not to connect with me directly. They can read through documentation and they can understand. They can read through documentation and they can understand. One more issue we need to put here: versioning also, versioning also, versioning issues. We will have versioning issues also. Okay, I'll add if I find anything else. Okay, versioning issues. Okay, so proper documentation we need to provide so that other teams can able to talk. Just a minute. Just a minute. Okay. Yeah. So proper documentation we need to provide just to explain about our microservice. Basically, backend will never worry about front end. You need not to know what is the front end implemented and how they implement it. Just we need to implement backend and we need to share proper documentation with front end or other microservices teams, because not only front end, one microservice may call by another microservice also, but that is also will happen through gateway only. You should not directly connect one microservice with another microservice. This is not good practice, but still I can see people used to connect it, but that is not the good practice. In case if you want to connect one module with another module also via gateway only, we should establish that communication. And configuration also need to be addressed. Configuration problems also need to be addressed here. As I said, microservices keep on increase. Maintaining configuration locally will not, if you maintain everything in local, maintenance will become too much difficult. Let's say a common url I am using across 10 microservices or 20 or 100 microservices. Locally I configured it within code in my application properties file, and I got a request to change it. Already 100 microservices implemented, but in that 100 microservices locally one common url is configured. Now when there is a request to change it, I need to interrupt all 100 microservices. I need to change the URL. I need to again test the complete applications, 100 applications I need to test. And then again I need to do lot of deployments. But if I have a common configuration which can able to change at any time from a central configuration server, which can modify automatically across all the microservices, that helps a lot, right? So such configuration services also provided to us. And common access or a common medium to access everyone is gateway. So we will address this issue using gateway. And security, we can apply security via gateway. We can apply security via gateway so that we can do easily authenticate or authorize the particular request which is coming from front end or another back end also, and we can able to proceed or reject that request within the gateway also. We can address security issue also. And data read write operations during implementation of microservices, usually to address this read write issues, right? Again it is recommended to divide this module into two separate modules, again each module into two separate applications, and implement separate read read-only operations and implement separate service for write operations. For doing create, update, delete, you can create a separate service, and only for read you can create a separate service so that easily you can address read-write issues. Using CQRS pattern we will do that. So this one also you need to remember to address this read-write issues. And versioning problems. We'll go in depth later. Okay. Just these all are the problems that we need to look into. Command query pattern, we call it CQRS command query pattern. Okay. And versioning problems also. Versioning issues we don't find here in monolithic. Let's say one change came in my backend. Client asked to change one URL or one input. Let's say from front end earlier I am sending name, email address, and now client asked to introduce phone number and location parameters also. So I'll do that front end changes. Accordingly, I'll go to the backend, and backend also I'll do the same changes. So that I need not to bother about informing changes to others, because I know what's happening in the front end, so that I'll do changes accordingly in the backend as well. As only single team is working, so there is no issue about the new changes. New changes will be communicated with both front end and back end. Let's say there are two separate developers. So front end person will do that two additionals in front end and two additionals in back end also will be changed, and it will be tested and it will be moved to production. That is fine in this scenario. But there is a change in the back end. So there is a change in the back end. One new requirement came and asked to add two more parameters in the module 1. So if I do that change without intimating to all other dependencies, I don't know how many using my microservice. As I said, let's say you have 10 front-end applications and 150 plus back-end applications. I don't know who all are consuming my microservice. If I do any changes, without intimating, or though you intimate it also, if they don't apply your changes immediately, from my business side, I want that changes, but maybe others may not require that changes. Others are comfortable with your old changes also. They may create arguments. We don't want to do any modifications as of now. Our application is, or our microservice is running stable. We don't want to apply your changes in our microservices. They may say that. Or you may need to give them time. You developed it, you got time, so you developed, you changed it. But other teams may not have time. They may have other important use cases that they might have been implementing. So immediately if you do your changes, additional features if you add and if you deploy it, it may break other applications. So how you can give solutions for that such scenarios here means by versioning we can do that changes. Means the old version code you should not change. As it is, the old version should continue. And if anything new required only for your team, you need to create altogether new URLs and you need to implement it. Maybe by using versions you can apply it. Maybe v1 URL, v2 URL, v3 URL, like that you can create. So that whoever is using v1 URL, when you apply v2 or v3 new URLs also you created, they need not to worry. They can continue with the old version code also. So during modification or during a request to modify it, directly don't modify any existing application. Instead you modifying it, recreate it. You should keep existing one as it is, and you should extend that, and you may need to create a new URL. That's how, without affecting other services, you can maintain your microservices. Excuse me. So versioning also important. When other teams realized that new version is required to them, let's say out of 100 teams, 2 teams realized that new version is required for them, they will upgrade their URL to new version. How they will know? Via documentation, they will know how many URLs you have, version 1, version 2, version 3, or they may connect with you which is the latest one. If you mention version 3 is the latest one, okay, they will get the changes from version 3 so that they can able to get the up-to-date changes into their microservice as well. So this versioning issues also we have to address. So just as a developer, you need to do all this versioning or data read write. You need to apply this as a common practices. Okay, documentation anyway. There is a tool to help you, and you need to know about how to maintain configurations centrally, and you need to know how to configure gateway, and we should know how to apply security. And again, it is a manual activity collaboration. Maybe your lead or a scrum master will take care of it. Let's see what are all other issues we have. Okay, this is for brand new microservice. Okay, so instead of going with monolithic, yesterday we see the benefits from the client and vendor side also, right? So a brand new microservice, if you are implementing a brand new microservice, if you are implementing, you need to follow this architecture and you need to implement it. In case if you want to migrate existing monolithic applications, right? Already thousands of applications has been implemented from last 20-30 years in monolithic style using Spring or Struts framework or JSF framework or using servlets, JSPs, or maybe using EJBs. If they ask you to migrate that monolithic application to microservice, are there any particular patterns do we have to migrate? For brand new, you can easily apply it. For brand new, you can easily apply it. Each module or each independent feature, you can create it as a separate microservice with separate database, and you can have a common gateway. Via common gateway, you can give access to front ends. This is easy. And when it comes to existing microservice, are there any patterns given? Go through this documentation. So just what I was saying is, if it is a brand new microservice, it is easy to design. Okay, so by following these patterns, just each independent module you can create it as a separate microservice, and you can connect to this microservice via gateway to front ends, and you can address all these issues by doing, applying swagger and config server pattern, by applying config server and gateways. Yeah, so we can address all these issues, which means we can introduce them. Versioning we can apply during new changes, and a data read write operations we can address. Security we can apply in gateway. Common access via gateway we can give. Configuration server we can maintain separately. From that configuration server we can give access of configurations, all the URLs, configurations, everything we can put it under config server. So via config server, all your local microservices can access their configurations. So we can have a config server for the configurations purpose. We can have configuration server for configurations purpose. Okay, so typically we can create a microservice like this, and we can address all the problems which are not there in the monolithic scenario. In monolithic scenario, we don't have all such problems, but you will be having here. So what is the advantage? Why I need to go through all these problems that we discussed yesterday? If I go with microservice, I can have lot of advantages here. I can have lot of advantages here. From the business side, if you see, instead of waiting for next 10 months, if I have 10 teams parallelly, they can design microservice within 1 month. They can deliver all of the microservices, so that my business can get up to speed, up to date application into the market. As soon as I thought a strategy, I can implement it and I can deliver that application into the market, so that I can increase my business and I can get lot of revenue. And from vendor side also, vendor can deploy multiple teams and he can deliver it so that he can get the, you know, whatever profit he needs. Instead of waiting for 1 year, he can get that profit within a 1 month so that he can shift to the next application or next clients, right? And he can use multiple technology people also here. Need not to use only Java people. If we have other people also who can able to implement, if they can provide REST services, we can easily connect with that microservices as well. So that all are the advantages. So as we have so many good advantages, you need to address these problems so that you can easily able to get the good business. Okay, now let's look into the patterns. See what experts are saying. Read through this documentation. Okay, so what are the microservices? Microservices, also known as an architectural style that structures an application as a collection of services. Okay, multiple services together, a collection of small multiple services together, calling as microservice. And independently deployable, loosely coupled. How they should look like: independent deployable and loosely coupled. While designing your microservice, right, these microservices should be independent deployable and loosely coupled. What that means, independent deployable means, I have done some changes here in the module 1, and you should not force other module teams to deploy your microservices also. So if you have such a dependency, you should not break down them into two microservices. You should maintain it as a single microservice. Okay. So when you apply your changes in microservice 1, you should deploy your service only. It should be independent to deployable. So that's how you should identify your module. That's how you should identify your modular feature. It should be independent, deployable. You should not force others to deploy their microservice also. Your microservice only you need to deploy as soon as you've done your changes. And loosely coupled, it should not have any dependency with other modules. It should be loosely coupled. Loosely coupled, we understand from the class to class, from controller to service, service to DAO, how we understand loosely coupled. Similar way, your microservices also should have a loosely coupled relationship. You should not force others to do the changes compulsory when you do the changes. Okay, so maybe via versioning we achieve it. Via versioning we achieve it loosely coupled and independent. And how you divide them? Services are typically organized around business capabilities. As I am saying, modules, each module is having a separate business capability or a separate business or separate solution altogether. So it can be organized. Your microservices can be organized or can be divided based on business capabilities or features. Each service is often owned by a single or a small team. Okay, each service can be owned by a single person or a small team. That's how we used to maintain microservices, because typically they are very small. Typically they are very small. Let's say you got a requirement today, maybe end of this week you can deliver the application itself. Let's say if they ask you to do CRUD operations on student, a student request is there, student name, email address, phone number, contact location. For all that details, I want to create a microservice for doing CRUD operations. When they give that requirement, easily you can develop it and deliver it maybe within 1 or 2 days. So it should be in terms, it should be very small. A developer can own it. A developer can own it, or a small team, 2 people or 3 people team also can own it. Depends on the size. The microservice architecture enables organization to deliver large, complex applications rapidly, frequently, reliably, and sustainably. It is necessarily necessity for competing the winning the today's world. That is what I'm saying. You got a business thought and you need to implement it very rapidly and deliver it very frequently into the market so that your application can sustain. If you see Swiggy, Zomato applications, they used to continuously add new features. Let's say Swiggy introduced one new feature immediately, Zomato also will catch that feature and they will adopt it. Otherwise, people will move towards to the flexible application instead of the old ones. And if you observe Rapido or the Ola, Uber, when one introduced one feature, others also will immediately adopt that feature and they will keep that application up to date. Otherwise, they can't win. So microservices will give you that flexibility. Let's say one new feature need to be adopted. Easily you can implement a new feature as a new microservice and you can add that feature in the front end so that your application is up to date. So new features easily we can adapt. For the current world, monolithic applications are not at all recommended. So you can go through this documentation. It will take time, but try to understand just by against the topics that we have discussed, right? So easily you can understand what experts are saying here. Okay, now I'll talk about migrating monolithic application to microservice and a full length architecture you have here. I'll explain you later. Okay, a big architecture of microservice. Okay, this is what basically basic architecture that you need to know first, and a full length architecture we have here. You can go through this document also. Open this image, you can see this. Okay, so how many patterns we have here, you can see application patterns, data patterns, maintaining data consistency problems, and what else, cross-cutting services, application architecture styles, security style, common communication styles, transaction styles, reliability, external access, observability. We'll talk about each. Okay, testing. I'll explain you each problem statement and I'll explain you why we need deployment, communication patterns all together. I mean, it depends on your application. It's not required to adopt everything, but all the best practices has been given here. Okay, so based on the application size or need, we need to adopt them. Okay, if it is relatively very small, keeping huge infrastructure also is not good practice. But if application is very big, it's good to follow all the best practices. Okay, so this is not a stable. It will continuously, when somebody identify a problem, maybe they might propose a new solution. That new solutions also you should adopt. Okay, microservices are continuously changing day by day, new solutions also coming in. But if you understand the common general principles, right, you can easily adopt them. Okay, migration of monolithic into microservice. We will follow a strangler pattern. Very good. Yeah. When you want to migrate old application to new application, then how we do that migration here, you can understand. Consider this is my old application, monolithic application I have here, and this application I want to divide it into multiple microservices. As this application currently in production, as this application is currently in production, I don't want to discontinue it. Let's say if it is a Citibank application, recently Citi sold out to Axis Bank. Maybe they might migrate all the features. So as of now, Citibank application is still running. Maybe slowly they'll migrate it to Axis Bank. How the migration might happening? City India consumer banking consumers are now serviced by Axis Bank. So maybe one by one, all the features they are removing here and I'm adding into Axis Bank. Okay. So now here when they want to migrate it from their old application to new application or existing somebody application to your application, you should not immediately discontinue it. It should be continued. It should be continued until everything is ready. How we do that? Let's say in the Citibank application, in the Citibank application, a customer consumer banking is first thing or internet banking is the first thing they want to migrate it. They have a lot of features here. They have a lot of features here, maybe loan application, consumer banking. Okay, they might have credit card banking. A lot of features they might have considered. I want to migrate internet banking first. So internet banking module only I can take it out and I can divide it or I can create it as a microservice here. And this microservice I can run along with the existing monolithic application. Only internet banking will connect with my microservice from the existing front end and all the features as is well continue with the existing monolith. Now next month I got some time. I want to move loan banking also to microservice. So I can remove that loan banking dependency from this monolithic and as soon as I implemented that in a microservice, right? Now front end application can continue with microservice for loan banking and credit card banking still there in the microservice. So credit card banking can connect with this microservice application only. Now slowly that credit card banking also move to microservices. Now just here user transactions related or the previous history information I have here. That one also I want to migrate. So that feature also if you migrate to monolithic by the time, right, all the features will be migrated into microservice and this monolithic application will be no more. So your front end now always it will connect with the backend microservice application and monolithic can be discarded. So this is how in strangler pattern, right, one by one feature we will remove from monolithic and we will add here. And if any new features, if you see green color, right, if any new features along with that old model if you want to add, you can add here. You have that flexibility as you are now going to introduce new internet banking, maybe along with the existing code, right? You might add new features which you wanted to add because now it is going for the change. If you want small changes here and there, you can apply it, or a new feature if you want to add, you can add on it. So that's how monolithic will be slowly slice by slice we will remove and we will create microservices. We call it as a strangler pattern. Strangler pattern is applicable for old application to new microservices. Monolithic to microservice application. This is applicable. This is applicable. Any questions here? Clear, right? Yeah. So if it is a brand new application, no worries. We can identify the features and we can implement them. But when it is a old application to new migration, right? Follow the strangler pattern. Okay. Dive little bit deep depth into each topic. Okay. I'm giving you very high level, but you dive into more in depth in case if you fall into any old application to new migration, right? Learn more about it. Nothing much, but integration you need to learn how you can integrate with the old monolithic with the new microservice both together, how we can communicate. Okay, that is the missing point that you need to learn. Okay, yeah. You can see is triangular application grows larger over the time, and monolithic will shrink over the time. Your monolithic will no more over the time, right? It will decrease the size, whereas this triangular application will keep on increases over the time, because you are removing features here and you are adding here. So over the time, the size will increase and the size will decrease. Okay, yeah, go through this one. Okay, we'll pick up design patterns from here and I'll explain you. Tomorrow we will see examples on it. Okay, we will see examples on it. We'll create small microservices, and we will see how gateways will work, configuration servers will work. Okay, one by one the solutions we will see. Okay, we'll pick up a small use case and we'll implement it.